Hi, welcome to Conceptual Physics with Mrs. Miller at BVISC. Today we're going to be looking at Chapter 9, Circular Motion. Circular motion is comprised of several components. We have the axis, as demonstrated by the pole here in the ride. We have the revolution, which is the external axis, which would be the people on the swings, and the rotation, which actually happens to be this particular part of our ride here. Now, you're going to be creating, or should have already created, your models of rotation, revolution, and the axis for circular motion. Now, the most important thing to remember is that rotation is on the internal axis and revolution is on the external axis. So you're going to see this on the Earth or on a bug on a CD. Now, the Earth rotates on its own axis, but it revolves around the sun, which has its external axis. So we can have rotation and revolution in the same system, just depending on where you see it from. Now we have the bug on the CD, where the CD rotates, but the bug has the revolution around that CD's axis. So internal and external axis is very important for circular motion. Now, circular motion has linear speed, or sometimes referred to as tangential speed. Now, linear speed we actually just called speed in these previous chapters, but in circular motion it's tangential speed, and here's why. If you take a look at this picture right here that I'm going to be blowing up, you're going to notice that as you're going around, you actually are looking at the tangent, or this red line. And that's really where you want to continue your motion, but it's this centripetal force that we're going to get to later that actually requires you to stay in that circular path. So that's the tangential speed. Okay? Now we also have that rotational speed. Now rotational speed is also known as angular speed. Now it's really the number of rotations per minute, or RPMs. Now you're going to see this with your car a lot, or with your truck. You're going to see RPMs, and there usually it says 1, 2, 3, and that would be in thousands, so 1,000, 2,000 rotations per minute. Now if you look at this system right here, we have a guy on a table, and this is very similar to what skaters go through when they, or ballerinas will do when they do a spin. Now let's just assume that this is a turning table. When we look at this, the man himself is actually doing the rotation while the dumbbells that he has pointed out are revolving. Well, when he brings it in, he's bringing the mass in tighter, so he's creating a even faster rotation. So when we actually look at this, what you're going to find out is that this nice thing right here, we're going to look at this equation down here. It says speed tangential is basically equal to the distance radially times the rotational speed. So you're going to see the S meaning speed, and that little subscript tangential, and that little tilde actually meaning approximately. D is distance, and then we have the subscript radial times the speed subscript rotational. So what does that mean? Basically it means the further out we go from our axis, the faster our tangential speed is going to be. Now, here's your listening check. Now I need you to read through all of these, take your time, and write your answers in your journals. You'll be turning them in at the end of this week, and you'll need to have these answers in here. So take a pause, read them over, and make sure you answer those in your book.